Starting chapter 3 or topic 3 today in Advanced Algebra 1. Make sure before you start watching these videos and start doing the homework that you have completed topic 2. That means that you've taken quiz 2C, that you've turned in all the homework for topic 2 if you want credit for it, and that you have contacted me and I've emailed you the test, you've completed it, and you've emailed it back to me. If you have completed topic 2, now you're ready to start topic 3. If not, I want you just to stop the video and I want you to go back and I want you to complete topic 2 before you move on. Okay, topic 3. These are the notes. They are available to you on PowerSchool. And we're going to talk about relations and functions. Okay, what functions are they are just equations. And we've been looking at equations in slope-intercept form. We've been looking at equations in standard form. We've been looking at equations in point-slope form. Well, functions are equations. They are the same thing. We're just going to show you a little bit different notation for those. Okay, a relation is a set of ordered pairs. I'll bump that out of the way. Let me go back. Okay, so a relation is any set of ordered pairs, and that relation can be given as coordinates like this. That's a set of ordered pairs. That would be how a relation could be shown to you. You've got tables here. This is a way a relation can be shown to you. These represent ordered pairs. Like this is the point 2, 0. This is the point 3, 1, and so forth. So a table represents a set of ordered pairs. And even what you call down here, these are mappings. These represent ordered pairs as well. I can see that 0 has a line that is mapped over to -2. Okay, I can see that 0 has a second line that is mapped over to +1. So I can create ordered pairs out of that mapping as well. So these are all different ways that a relation might be shown to you on this assignment and in this chapter. Okay, a function is a relation in which each input is assigned to exactly one output. And what that means is that your x value is not going to repeat. For example, when I look at the ordered pairs here, I'm going to see that I have 2, 0, I'm going to have 3, 1, I'm going to have 4, 2, I'm going to have 5, 3, I'm going to have 6, 4. All of these x values are unique. They're different, which means that each input, x's are inputs, y's are outputs. Each input is assigned exactly to one output, so the x doesn't repeat. So therefore, it is a function. So really what you want to do is you want to just look at the x or the domain. We're going to say that all of these values are different, therefore yes, it's a function. Now if you'll notice that down here when I started listing the input and the outputs from this mapping, I said that 0 had a line drawn to -2, that was one ordered pair, but 0 had a second line coming off of it which mapped to 1. That is not a function, because the x value is repeating. We see 0 mapped to a different y value, so that would be not a function. That's what it means by that. So up here I'd see function, let's say each x value is different. No repeats. Might want to put that in your notes. Okay, the domain is the set of the inputs or the x values. So the domain of a table like this, these values are my domain, and then the range are the y values. So everything down here would be considered a range. It's alphabetical. X comes before y in the alphabet, domain starts with a D, range starts with an R, D comes before R in the alphabet. So domain goes with x's, range goes with y's. Okay, so some of the questions that you're going to be dealing with on your assignment will look like this. For example, 1, it says identify the domain and the range. So I'm just going to write down on my paper domain, and we're going to put this in set notation. So we're going to put a little brace like that, and I'm going to list my values. I'm going to say 2, 3, 4, 5, and 6 are my domain values, and my range values, okay, it would be 0, 1, 2, 3, and 4. And that's how I list my domain and my range. Okay, same thing with example B. You'd say your domain values are -3, -1, 1, 3, and 4. And your range values would be 1, 3, -2, 2, and 6. You don't have to put them in numerical order. You can if you want to, but you don't have to. And if values repeat, let's say I had a table of values like this, where I said 1, 2, and 3. Those are my domain values. And let's say I had 0, 1, and 1. When I list my range values for y, okay, I can just list 0 and 1. If you have values that repeat in your table, you don't have to keep listing them as your domain, as your range. You just have to list each number once. Okay, example 2, it's asking you if the relation is a function. Remember we talked about above how it's a function if the x value doesn't repeat. And we already talked about how there's two lines coming off of 0, creating 0, negative 2 as an ordered pair, and also creating 0, 1 as an ordered pair. Since that 0 is repeating, we would say not a function. Okay, this mapping, you can see you have one line going to a distinct number. So 3 is mapped to 10, so 3, 10 is an ordered pair. Okay, 2 is mapped to 8, so 2, 8, 1, 6, 0, 4, negative 1, 2. Okay, and this, if you look at the bottom ones here, let's do this. Negative 1 is mapped to 2, and negative 2 is mapped to 2. That is still a function. Okay, yes, function. And the reason it's a function is because the x values aren't repeating. Now the y values repeated, but the x's didn't. And so when the x's don't repeat, it is a function. Now what we're going to talk about what a one-to-one function is. It is a function, and it says a one-to-one is a function in which no two elements of the domain map to the same element in the range. That means the y's don't repeat. Y value does not repeat. Okay, so example B up here, it was a function, but it's not a one-to-one function because you see those y values that are repeating. So I'd say yes, it's a function, but it's not one-to-one. Okay, this was not a function. Up here we had a function because all the x values are different. That's a function, and you can see all the y values are different. So you'd say yes, it's a function, and then yeah, it's one-to-one. Okay, so was example B. Example B was a function, and it was also a one-to-one function. Okay, so you're going to get to answer, is it a relation, is it a function? If so, is it one-to-one? We kind of just did that. To see if it's a function, you're checking out the x values. Are those x values all different? And they are different values, so I'm going to say yes, it's a function. Okay, then to determine if it's one-to-one, once I've said yes, now if I say no, it's not a function, don't worry about one-to-one. It's not a function. But if you say yes, it's a function, now we got to look to see if it's one-to-one. Now I'm going to look at the y values. Are the y values all different? And those y values are all different, so I would say it's 1 to 1. Okay, if I look at this mapping down here, I can see negative 2 is going to 5. I can see 3 is going to 6. And 3 also has a line going to 7. So I'm seeing right now that my x values are repeating. So this is no function. Not a function. And if it's not a function, you don't even worry about the one-to-one part because it's not a function. Okay, with this, when it's a graph like this, you could go along and you could try to pick out all these points and figure out if the x value repeats or not. But here's a quick test. Anytime it's graphed for you, we have what's called the vertical line test. And if you were to draw a vertical line through that graph, if it touches the graph more than one time, it is not a function. If it only touches the graph once, which right there you see an intersection point one time, it is a function. Yes, function. Now, are the y values all different? Well, the only line where the y values are the same is a horizontal line. Okay, so this would be one-to-one. Okay, remember that horizontal line that we saw in topic 2, where all the values on here have the same y value? Okay, that would be an example of something that's not one-to-one. It's still a function. Okay, it still passes the vertical line test. It's still a function, but it's not going to be one-to-one. Okay, let's see what we got at the end here. It says analyze each situation, identify a reasonable domain and range. Basically what we're asking is it okay to have some negative values? Okay, when I look at an airplane traveling at 565 miles per hour, what I'm considering is the distance. This is like saying distance equals rate times time. So I'm comparing distance is my range. Okay, that's kind of the y by itself. Distance is the range, and the time is equal to the domain. Okay, so what kind of time values can you plug in? Well, the question is, can you travel a negative amount of time? And the answer is no. So you would say for your domain, my domain would have to be greater than or equal to 0. And my range values, can we travel a negative distance? And that would be no also. So I'd say my range is greater than or equal to 0 too. Now you could say D is greater than or equal to 0 and T is greater than or equal to 0. They really didn't give us variables to work with, so I'm just going to say the domain is greater than or equal to 0, and so is the range. Tickets to a sporting event cost $125. So what's my range here? And my domain? My domain would be probably the number of tickets that I'm buying. So I would say domain, again, greater than or equal to 0. I can't buy -2 tickets, but I don't have to buy a ticket, so I could be 0. But when I start buying tickets, it's going to be greater than 0. And then the range. If I don't buy any tickets, I don't spend any money. And if I buy a ticket, I'm up to $125. So again, I'm going to say greater than or equal to 0. Average person consumes 2,000 calories a day. Again, all of these are examples where negative values cannot be plugged in, so it's just greater than or equal to 0. So it's just getting you to think about what kind of values can be plugged into the function, what's realistic. Okay, and then lastly, it says identify the domain and the range when you can see the graph. Okay, so the domain are your x values again. Okay, and since I have a graph, I'm going to say x's. Now if you look at your x's, here's a definite point right here, and then the graph is just going to the right. It does not go to the left at all. So what's the x value at that point? Well, that point is at 0, 0. Okay, so the x values have to be greater than or equal to 0. It's going to keep going here. All these x values are graphed, everything that's positive, so greater than or equal to 0. And then the range. The range are your y values. Okay, so what's the value here? The y value is 0, and then you can see everything under here is negative values. And this is going to keep going, and as it goes out, it goes down a little bit farther, a little bit farther, a little bit farther. So we say the y's are less than or equal to 0, because they're going to be all in the negative. It's not going to jump up here. It's just going to keep traveling down and get lower and lower and lower. So we'd say the domain is greater than or equal to 0, but the range is less than or equal to 0. Okay, over here, I've got a definite point that I'm starting with. Again, what's the coordinates of that? That coordinate is 0, -2, it looks like. So my domain, what are my x values going to do? Okay, well, the x value is going to be 1, is down here at 1, 2 is up here, 3 is up here, 4 is graphed, 5 is graphed, and this is going to keep going. So all of these x values are going to have a point to plot on that line. So again, I'd say x's are greater than or equal to 0. Okay, there's nothing over here on the line. It started right here. There was no arrow going here. So it started right there. It's got to be greater than or equal to 0. And then the range. Okay, for a range value, what's the lowest y value that it could possibly be? Well, here's the point that it started with. It had a y value of -2. And then is the y value increasing or is it decreasing? It's going up. So my y's are going to be greater than or equal to -2. So again, it's just getting you to think about what values you could plug in for x and what values you could use for y. Okay, give that worksheet a shot. And if you have any questions, join the Zoom or shoot me an email. But definitely join the Zoom.